well start already. I wonder if it's in a bit. Hey, don't. Oh, there you go. Now it's live. Oh, I'm watching my own live stream. Okay, there you go. It's live. I wonder how I'm gonna be able to keep track of comments. Oh, maybe I can keep track of it on my phone. Alright. Sige. Let's see. Hello, can you guys hear me? Shut up, Rick. Oh wait, why am I on this side? I should actually go back to first. Okay. I'm just waiting for them to, like, you know, say present. Actually, let me check out how many are watching right now, so you can actually see that there's one person watching. That's me. Isn't that nice? It's pretty clear with them though. Like, you know, we start 1:30. I even did the countdown, right? Oh, there's one. Okay, nice. So, I think we should wait for the others. Oh, Fiones. What the heck? Four people, nice. If this gets to at least 5 people, I think we're... Yeah, I said Fiones. Once it's 5 people, I think we can start, don't you think? That's the bare minimum. Well, that's fine, I guess. 7-second latency. What? Say something. What? Oh, there you go, 5 people. We're going to start now. Let's begin. So, C++. What is it? What is C++? Yeah, we're this guy right now. Huh? Well, basically C++ is an extension of a pretty old programming language like C. You know, I think it was invented like around 1970s or something. Anyway, It's a general purpose programming language. You know, it's used in games, it's used in business software, etc. It's also an object-oriented programming language. You don't need to know what that means right now, but you know, that's just a fact. Anyway, it's also really fast. It's one of the fastest programming languages. That's why I have this really crappy Sonic drawing right here. That's C++. And then it's also pretty fun. At least I hope it will be for you guys. So why are we learning C++? It has few keywords and it uses concepts that most other programming languages also implement. And yeah, that's why we're learning C++. Also, it's unlike other programming languages, it actually has less features in certain areas, so it's a little bit more of a pain in the butt to use. So, you know, because of that, you guys will find that once you go from C++ to other programming languages, you'll find that it's actually easier, like in other languages, because C++ was really difficult. Anyway, let's begin. What are we going to make today? Well, we're going to make a Hello World program in C++. Actually, wait. Are there any questions before we proceed? Like, are there any? Oh man, you can hear the Cheetos. Oh, no questions. Okay. Oh man, I can't seem to. There you go. Okay, if there are none, then we'll just continue. So we're going to make a Hello World program. Like maybe some of you have already tried that. Basically, a Hello World program is just you print out Hello World to the console. Like, it's kind of a traditional thing. Like when you're learning a new programming language, you have to like you have to do some sort of version of a Hello World program. Like you test out, you know, like maybe a basic feature of the like programming language. You know, basically that's what the Hello World program is. Like it literally just prints Hello World. So the next slides actually are gonna walk you through Visual Studio, but maybe we don't need to do that anymore. Like maybe we can skip ahead to the code. So let's just go to the actually, you know what? Yeah, let's go through the how you use Visual Studio. So like Visual Studio is one tool you can use to like create C++ programs. And then the nice thing about Visual Studio is like well, you get to run stuff like on the console, but you can also like create desktop applications, but that's a little more complicated. Anyway, so create a new project, create a Visual C++ project, but we don't need to do this. Actually, what I suggest you do is you go to a site called REUPLOAD.it. It's an online compiler. The nice thing about it is it works just like Visual Studio, except it's online and it saves all your codes, and also like you get to share it to other people. So like, you know, if you need help, like you can just send a link to the code. So anyway, yeah, check out the link I just sent to chat. Anyway, let's continue. So let's actually skip through this stuff. The important part is the code here. So first things first, let's get rid of that line there. Yeah, let's replace it with include IOStream, then int main return 0. So this thing here, this is what your first C++ program looks like. It's pretty empty. You know, it's only a few lines, like maybe around 5 or so. If you get rid of this, like how to make a console applications.cpp, and yeah, if you get rid of that, it's very short. 1, 2, 3, 4, 5, 6. So, let's try to understand what's going on here. What's this? What's that? What's that? So, actually, before we do that, let's actually make the hello world part. So, type this next. std and then 2 characters and cout, then 2 less than symbols, then double quote hello world, end quote, then double less than, and then std and then double colon, and then end line, end l, then a semicolon. So if you run this program, you should get hello world. Like, it will print out hello world. So it's pretty simple. Sucks that the stuff here is specific to Visual Studio, but anyway, we don't need to do this get car anymore. But if you're using Visual Studio, you should put that get car, this thing here, so that when you run it, it doesn't die immediately, because that's what happens. Because how it works is, you run the program, and then once it's finished, like printing hello world, that means the program is done. Once it's done, well, it dies. So, actually, are there any questions? Like, is anyone like having a hard time following? No, at least like, say, oh, okay, sure, Fiona. How about the others? There are 2 other people there, I think. Okay. Well, we'll continue. So, that's our Hello World program. We actually just finished our first program. So what can we learn from this program? This is where we start to analyze what we just wrote. So C++ is just like any language. It has rules, like for grammar. So first things first, if we just type out like our C++ code really quick. So if you remember, we have include IOStream, and then we have int main, and then we have a return 0, and we have std cout hello world, and then end line, std end line. So notice that each line inside int main ends with a semicolon. In English, that's like ending your sentences with a period. So because the programming language itself is kind of stupid, doesn't know that when you put a new line, that means, oh, it's another thing. Some languages do that though, but C++ is particularly stupid. But it's okay, because then, as most programming languages are as stupid as C++, you really need to put a semicolon at the end to tell it that, this is one line, one set of instructions, and this is another, this is separate. So don't get confused. And then, okay, another thing we can learn is that there's this first line here, this include IOStream. So this hash include, and then less than IOStream greater than. It includes something from a library. So basically, a library, it's like a real life library. It's code that other people wrote, and decided to be kind enough to like let you use. That's oversimplifying, but yeah, that's what the library is. Like, it's code that other people use, and you get to use that code for different in different ways. Like, the code we're using in particular is this std cout. What this does is it prints stuff out to the console. So in this case, we're printing out hello world. We wouldn't be able to do that if we didn't include the library. This library, IOStream, is what's responsible for printing out and taking user input. So if you want to like have some sort of program where you're asking for example, 2 numbers, and then you want to print out their sum, then if you for your program to take in those 2 numbers, you have to include this library. Okay, so Yeah, basically a library is a collection of code that other programmers wrote to help out other programmers. And then an IOStream is a header that it's a header. Okay. We should discuss what a header is. Like a header is like that's just the type of file extension it is. It's just but basically a header contains the implementations of all the code that you're using. Like somewhere out there someone wrote all the code that makes stdc out work underneath the hood. So it's a header that belongs to the input or output library. And this input or output library is part of the bigger collection of libraries called the C++ standard library. So anyway, yeah, that's a header. It's just full of variables and function definitions. We'll find out what those are eventually, but variables, yeah, we'll learn that today. Anyway, so that's how you include a header, but you don't need to worry about that right now. So what is STD? Well, there are many possible meanings for that. I mean, who knows? Like, it could mean sexually transmitted disease, self-teleportation device, super titanium, DeLorean, but really what it means standard. So STD is what is known as a namespace. Namespaces group things into their own scope in order to avoid like collisions in their names. We don't need to worry about that too much for now, but just think of STD as a way to access C++ standard library. That's a way that you can access cout. This double colon, it's like you're saying, hey C++, go into STD and take cout from it, and then let me use it to print out hello world. Then this part here, hey STD, give me the end line character. So I just changed that at the end. Anyway, so once we're done with that, well, actually, why do we have to keep typing STD? We don't. We don't. We can do this. We can use the namespace STD. It's like you're putting the entire program in the same scope as STD. So now you don't have to access STD manually because you're already in STD. You're using it. You're using the namespace STD. So now you can change your code to this, which looks a little better. So anyway, what does cout stand for? So like cout stands for console output. And then how about endline? I mean endl stands for end line. And then cout allows you to chain together like these strings, this text, in order to print multiple things. So like for example, you want to print out hello, my name is Red. You can sort of do it like all in one block, or you can do it like this. You have cout less than, these two less than chains together different strings of characters and text and variables, which we'll learn about later. So it strings them together. This hello, my name is stringed together with Red, then it's stringed together with this end line character, and it prints out hello, my name is Red on a new line. Anyway, actually, you might be wondering, how come I have to have this endl every time? Because like if you don't have this endl, it will print it continuously without putting it on one line, because C++ and other programming languages aren't that smart. So you have to specify that I want it on I want it on one line. So yeah, that's what end line is. Actually, more specifically, like this end line is actually a character. It's special, like it's a special ASCII character. Well, we don't need to worry about what ASCII is, but actually one way you can type out end line is actually you can type it like this. You have to use the, I don't know if this backward or forward slash, but slash and then n. This prints out a new line. I mean, this is the same thing as doing endl. So it's, just choose what you want, because like it does the same thing. So believe it or not, this this thing here, this is like a special character in the keyboard. Well, not the keyboard, but like something known as the ASCII code. If you want, let's peep the ASCII code for a bit. ASCII code. So this is what the ASCII table looks like. You have some sort of number assigned to each possible character you can type. You know, you have 65 for capital A, 97 for small a, etc. Somewhere there's a new line character, but I don't know where it is. Anyway, let's continue with the slides. That was a bit irrelevant, but anyway. So now we know how to print anything. We can print out we can print out you know, we can print out you know, kill everyone, just like this. We can also print out screw life. I don't know, or you can print out something positive like let's eat marshmallows together. Anyway, you get the point. So that's how you print stuff. So now you know how to do one thing. But the thing about this is, this one thing is not enough. It's not interactive. Like, it literally just prints something out. Like, you know, you don't need a printer. You need a program, right? You need it to interact with you. So that's what we're gonna try to do next, which is we're going to make it interactive. Oh yeah, before we continue, are there any questions? Oh wait, where's the slide? YouTube, okay. Are there any questions? How about the others? Okay, nice. Let's continue then. Yeah. You know, those drawings were lovingly made for you guys. Anyway. So, how do we make this program interactive? Oh yeah, actually, are you sure there's like no questions? Like, any clarifications? Like, you know, how does CIIT work or something like that? Like, more specific stuff. Like, is there anyone confused with our basic Hello World program? Okay, what? Specs Daddy. Alright, cool. It seems like there are no questions. Like, we'll continue anyway. So, now that we can print stuff out on the console, we're going to make this program interactive. It's like, we're not gonna print the first 15 Fibonacci numbers though. We're just gonna do something simpler. So, you know, this is the program. Hello world, this is what they've written so far. It's a dummy. And we're trying to poke it and, like, you know, hey, give me 15 Fibonacci numbers, but it's giving me hello world. Anyway, but what we really want to be able to do is, like, want to make a program do something based on stuff that the user enters. You know, like, when you enter two numbers, I want to print out the sum or the difference or the product, like a calculator. So yeah, like, or like this, you know, user enters age, are you a legal adult or not? You know, user enters his grade, or did you pass or did you not? But wait, how do we actually store that information that we take from the users? And luckily there's a way to do that in programming. So that's where we have variables. Yeah, so variables, like, one way you can think about them is they're like boxes where you can store any information. So actually this shouldn't be an int, but anyway, basically, you know, there's the box somewhere in memory, because, like, the way computers store information is you have something called random access memory. That's what RAM is. RAM is random access memory, because here, it's random access memory because when there's no specific location where it ends up. It just kind of ends up randomly. as long as there's space. Anyway, somewhere in the computer there's a credit card number box that you created, and then you can leave the credit card number in there, and then yeah, and then you can use it. You can print it. You can modify it. We'll learn how to do that in a bit, but conceptually, a variable is just a box where you can store information. So, yeah, what are they exactly? Yeah, boxes in memory. Memory as in random access memory, not memory on your hard drive. That's actually important. Like, memory on your hard drive is different from random access memory. It's like, memory on your hard drive is permanent, but random access memory, it's temporary. It's like once you close the program, you know, let's say this credit card number guy, this cute little box here, he's gone. Like once you close the program, like he's dead. Which is pretty sad, but that's how it works. It's temporary. Because you don't always want to have, you know, a credit card number box open all the time. You could use that box for something else, so you don't always need it. Anyway, that's random access memory. So basically, you know, there is like, you know, variables in algebra, right? Like you have x as like some sort of unknown quantity. Then you manipulate an expression, like, you know, you do like transposing, and then you get the answer you want. Yeah, that's variables in algebra. But variables in programming are different. I'd say that variables in programming are actually more flexible. It's like variables in programming are just like boxes. You know, you can do more with boxes than just unknown quantities. It's like boxes contain stuff. You know, a variable in algebra is like a stone. And then a variable in programming is like a stone with a hole in it that acts like a box. Anyway, so another thing you can notice is that, you know, variables in algebra are usually just one letter, like x, y, z, a, b, c. But in variables in programming, they can be anything. They can be red. They can be unlucky number equals 13. So the value of the variable is either set before running the program, or it can depend on the user input, and we'll learn how to do that in a bit. So this variable name, there are actually some rules to it. Like, I did say it can be anything, but you can't put spaces in between, for example. So the reason that you can't is because the way C++ reads it is it looks for what type is this variable. Here it's an int. We'll learn what that is in a bit, and its name or identifier is unlucky number. Then its current value is equal to 13, and then semicolon. So if you have a space there, it will see the, if it was like, let's say you have the same unlucky number, but you separated by space, equals 13, it will read the type, it will read the name as unlucky, and then it will look for an equal symbol here, but it found number, so it will give you an error. Like, what's this? What is number? I don't understand. Beep beep boop boop. I'm a computer. So yeah. That's why when we are creating variable names, you either get rid of the space, then like capitalize the next word, or you put an underscore and then you put the name of the variable. So yeah, that's how variables work. But we'll go into more detail, like, you know, what's an int? Like, we'll go into that. So that's where we have primitive data types. So thing is, like, there are like atoms in programming languages, like primitive data types. Like, you know, what I mean is, like, you can't decompose them further. Like, for example, can you think of a way to like decompose 12 into, like, I don't know, like, maybe you can decompose it to 0101 or some sort of binary string, but, you know, it's really just an integer. You know, that's as simple as you can go. Additionally, like, can you really decompose, like, for example, a single character like A any further? Like, it's just A. Anyway, they're primitive. Like, you can't go more primitive than they are. So What are they? They're like the atoms of a programming language. They're the basis for more complicated data types. So, well, it's okay if you don't get this joke here. Basically, you can kind of put them together and then you get a new data type altogether. So that's a nice thing about these primitive data types. You can combine them, then you can do so much with it. They're just like atoms in the universe. Anyway, so there are different types of primitive data types. So you have integers. This is the same as the mathematical integer. That's positive and negative values, including 0, but no decimal. Then we have floating point numbers, or doubles. So all these they're just decimal numbers. They're both negative and positive, and they can accommodate more double in particular is different from float because double can contain more decimals. Float, it's just a tiny, it's a tiny float. I can only have a few decimal numbers. Unlike double, you can probably go like really long, like super long. So, that's floating point and double. Also, we can learn that there's a sort of syntax here. There's a pattern. So, you have the data type, which is here, it's int. Then the name of the variable, random integer, and then you can either just end it there and then set its value on another line like this. Random integer is 10, or you can put it all in one line like this. The name of the the data type, and then the name of the variable, and then what is its value. In this case, it's -10. So the same syntax applies here, except it's a little different now because like the value is different. But yeah, there's a common syntax. So next we have characters. Those are single characters on your keyboard. Single letter, number, symbol, like the A or at, and so on. And, same syntax. Variable type, name of variable. You can either set it on a new line or you can do it all on one line. Just like that. And then we have Boolean. This is a variable which can be either true or false. So it has only two possible values. I'm either true or I'm false. You'll see why that's useful eventually, but for now, it's good to know. Like, this is what a Boolean is. Like, if you want to represent like a way, like bool alive, and then you can just set it to true. Or if you're feeling dead inside, Anyway, so now let's talk about basic operations and no. Questions first. Are there any questions? Any clarifications? Okay, anyone? Any questions? Man, why can't I type? Yes, those are Cro-Magnons. Anyway, so are you guys still with me? Anyway, let's continue. This will be recorded anyway, so it's all good. So now let's talk about basic operations and variables. Thing is, it's all good and fine that we can set variables, we can create a new int like age equals 18, something like that, and then we can actually print it out like that. But sometimes you don't want to have it always as 18. Like, you get older over time, so maybe you want to increase age by 1. How do we do that though? So that's what we're gonna learn, stuff like that. How do we change our the value of our variable? How do we manipulate it? So first things first, we actually just learned the first operation. It's the assignment operation. So that's the equals and then the value here. that's what you do to set the value to a variable. You can either do it once you create the variable, or you can do it later on in the code, like this. Variable name equals some value. Huh? Anyway. So yeah, that's the assignment or initialization operator. So next we should actually learn how to get user input. You know, we actually know how to store stuff already. We just need to know how to get like the stuff that the user types. So the way we do that is we use something called CIIT. So CIIT stands for console input. So there's a little difference between COUT and CIIT. So COUT looks like this. Hello world. But CIIT looks like this. Just create there. So, you know, we'll explain why it looks like that. It actually makes sense if we like, you know. Anyway, whatever. Let's continue. Oh wait, no, not yet done. Oh wow, I didn't finish it. What the heck? Anyway, let's continue. So this here prints out hello world. One way you can think about it is like, here, let's open up MS Paint for a bit. Oh, what the heck? So if we just open up MS Paint for a bit, the way you can think about it is like you have your computer program sitting in the middle of two streams. So this guy, you know, he's just waiting for a banana. I don't know what creature that is, but he wants a banana. And then there are two streams here. One's going this way, one's going that way. So the way this works is this guy, you know, this here, you're here, alright? This is us right now. We're the zookeeper. We have a banana. This is our data. This is our input. Or input. And then we can choose to drop that banana into the water. You know, just like that. Then like this monkey guy, he decides to catch it. You know, and hold on, let me just change his arm to catching mode. Like that. So he catches it. Then depending on what you taught the program to do, then he will either you know, eat it, you know, or he will return it to you. So, you know, let's say he was nice today, decided I wanted to return it to my owner. So here it is. It's traveling down the stream and goes back to you, the user. So that's how it works, and this will make more sense once we put in COUT. Oh wait, text too small. Oh, what the heck? Why is my PC lagging? Okay. It's so weird. I swear this happens all the time. So let's change this to COUT. Well, actually makes sense. Like, this is COUT, where it returns stuff to the user. Then this here is CIN. Notice that it looks exactly like our code. So let's go back to our to our code. COUT. So like we said, when we use COUT, the monkey returns the banana. So here's the banana returning. We're returning hello world. But in CN, we're giving the monkey a banana. Age is the banana. That's how it works. It flows down this stream and then goes down to like the monkey. So there you go. That's how you take in user input, and we'll get to practice that in a bit. Oh yeah. What do you guys think? Do you think it's still the same banana when you return it down the stream? Do you think this banana can change? Like, what do you think, guys? Yes or no? Man, can't type. What a weird question. What do you guys think? Does the banana change? Okay, like the banana stands for data. Okay, just for clarification, we're not talking about literal bananas here. Okay. So what do you guys think? Like, can it change later on in the program? Just a yes or no. Are you guys still watching? Come on. Hello, Fiona. Fiona, are you watching? Is this life or death? Does the banana change? How about you, Eliza? So yeah, guess what? It does change. Cause like we learned earlier, you can actually change the value of the data. Like if we're storing the data in age, we can actually change it to 19 or something, then return that. Oh no, like that. So we can actually do that, and that gives that returns the new age. Let's say your age was 18 initially. That's what you dropped into the pool. I mean the stream. But then the monkey decides that he's gonna give you a little extra. I'm gonna make you older, and then I'm gonna give it back to you. So, yeah, it can actually change. So, for now, like, yeah, that's one thing you can do. Like, you can change it from a different, you can change it into a different value later on. Oh yeah, it seems like my slides aren't complete. That's just kind of embarrassing. But we can actually continue the lesson here. I'm playing old Sublime Text. My favorite text editor. Anyway, so we learned about the assignment operation. All that is just the equals thing. This thing, like age equals 18. And so on, or like int age equals 18 when you're declaring the variable. But there are other operations you can do. So there's the mathematical operations. So after we learn this, let's we'll be done. Okay, so stick with me a little longer. So mathematical operations, what those are is your typical stuff, your addition. That's just your plus. And then you have your subtraction. That's just your minus symbol. Then you have division. That's just a slash. I don't know if that's forward or backward slash. And then there's multiplication. That's your asterisk character. So these are your mathematical operations. If you want to let's say you want to make yourself 10 times older. That's pretty dark. But okay, let's say we want to make yourself 10 times older and your current age is 10. Let's make him older. So the way we do that is we set age to be age times 10. So what ends up happening is when you print it out, you will print out 100. So yeah, you see what's going on here, and let's not be so dark. Let's say we just want to age you by 10 years, not age yourself by, multiply your age by 10. That's so bleak. Let's say you just want to get 10 years older. Now you're 20. Now, let's say you want to make yourself a fetus. You you subtract 10. Now you have 0. Your age will be 0 if you print it out. Oh yeah, here's another thing you can do. Like, you can add comments in your code, like, dear person, pardon this code. If you were particularly bad at writing code, you can apologize to the person in advance, like, hey man, sorry about that. Anyway, yeah, so age minus 10, that makes you 0 years old. Then let's say you want to, like, divide the age by 10. You want to make him, like, you want to make him 1 years old, for example. Then, that's what you do. You divide by 10. It works just like math. It's math. It's, addition, subtraction, multiplication, and division. And then, you combine it with this assignment operation in order to change the value of the variable. And, you'll get better at that through practice. So, now that we learned that, we actually know enough to do the exercises. So, there are some exercises that I suggest you try to do. So, first exercise 0 is, create a program that takes in a name and then prints out hello name here. Actually, hold on, I forgot something really important. So what if I want to get a name, right? So thing is, there's a special data type for that I didn't discuss. It's called a string. All this is it's a text. So let's say it's name. Then we use cin name. What this does is the user types in some text, and that's his name. That's how it works basically. So if I run this, then it will give me it will ask for my name. When I type it, it will do stuff with it. Let's say let's print out the name. So just like that. That's how you print out the name. And then remember that in CIIT you can actually change stuff together. Actually, right now we're doing that exercise. So we have this hello, right? But we want to also say hello to the name. So the way we do that is we just add another set of di pa nila nakikita yung finger ko. Anyway, so you can just add less than here, like 2 less than symbols, and then the name of the variable name. And then what this will end up printing is it will print out hello red or something depending on what you type. And actually, let's go a step further and let's use REUPLOAD. It's like we might as well learn how to use this. So REUPLOAD, this is an online IDE. Let's see, share code to others. So it's really convenient. So okay, don't need to worry about that. Let's just type our program here. Include IOStream. Remember, we have to include the input library. You put main. This is where our code goes, inside this body here. And we have return 0. Actually, I didn't explain why there's a return 0, but we'll go to that eventually. So what was the exercise again? We were trying to take in the name of the user, then print out hello, and then name here. How do we do that? So first we declare a string variable. Let's call it name, and then we use, oh wait, don't forget using namespace std so that you don't have to type it over and over again. So cin, remember cin goes right, it goes to the right. So that's where the stream with the monkey is pointing this way. The monkey's sad now because I put his banana behind him, so let me just move that there. There you go. Let me change his frown as well. Let's make him happy. Let's go back. So anyway, we take in user input using cin, then we print out hello, and then we print out name, then we print out end line. So let's try that. And then we set the input here, because like the thing about REPL is it doesn't have a live console, so you kind of have to type it yourself. Or actually, hold on, let's try this. Oh yeah, you can actually type it yourself. So let's say our name is Red. It will print out hello Red. See? Magic. Okay? Cool, right? So there you go. That's hello Red. So we just did exercise 0. And we applied the concepts we just learned. Like how to declare a variable, how to take user input, and how to print stuff. And we also learned how to manipulate the variable. So we can actually, if you want, we can change his name to nobody. Well, that's pretty dark, but I mean, let's try that. If you type Red, you'll be nobody. No matter what. It's so sad. Anyway. Yeah, so we learned how to change the values of a variable. And we also learned how to actually create the variable. So now we can do a lot with that now. We can create a calculator even. And that's what the other exercises are. So here, I want you guys to try this out on your own. Try out exercise 1, 2. I don't need to do the exercise 3. That's hard. Actually, wait, no. Try out exercise 3. Just don't do the hard mode one, okay? So try out these 3 exercises. How do you draw stuff there? Okay, so yeah, this stuff. This here. Wait. Is there no, there isn't. Okay. So, that's it actually. This is the end of our lesson. Are there any questions? Any questions, Fiona? Okay, cool. So I want you to try that out, Fiona. I want you to try out these 3 exercises here. I'll post the slides somewhere in a bit. So, now we're done, okay? And hopefully YouTube will upload this stream for everyone to see. And anyway, yeah. There you go. There you go. We're done. Thank you for watching, Fiona.